Hey, I'm Nogs, and this is Nogs House. Today we are going to talk about early Earth conditions. Imagine traveling back in time 4.5 billion years to see what Earth looked like right after it formed. What you'd find would be absolutely terrifying. Early Earth was nothing like the beautiful blue planet we know today. Instead, it was a molten, chaotic nightmare, a glowing ball of liquid rock constantly being reshaped by enormous forces. Volcanoes erupted everywhere, the entire surface was an ocean of magma, molten rock, and giant space rocks were constantly crashing into the planet with explosive force. The sky probably glowed red from all the heat, and the temperature at the surface was hot enough to melt lead. This era is called the Hadean period, named after Hades, the ancient Greek underworld, because it was so hellish and inhospitable. But here's the amazing thing. This violent, chaotic time wasn't just destruction. It was actually a fundamental crucible. That means a severe test or trial, but also a container where metals are melted and purified. The Hadean period forged our planet into what it would become, and during this time something absolutely incredible happened. A cosmic collision of unimaginable scale that created our moon. We're going to explore this wild, violent time in Earth's history and see how chaos eventually led to the world we know. The Hadean period lasted from about 4.54 billion years ago, right when Earth formed, until about 4 billion years ago. That's over 500 million years of extreme conditions. This was the earliest eon in Earth's history. An eon is the largest unit of geological time, lasting hundreds of millions or even billions of years. During the Hadean, Earth's surface was almost entirely molten. Remember how all those planetesimal collisions during Earth's formation released huge amounts of energy and created a magma ocean? Well, that molten state lasted for a long time. The surface temperature was probably around 1200 degrees Celsius, about 2200 degrees Fahrenheit. Hot enough to glow red hot like molten lava. There was no solid crust yet, or if there was, it was constantly being melted and reformed. The landscape was completely scarred by bombardment, meaning Earth was constantly being hit by asteroids, comets, and leftover planetesimals from the solar system's formation. These impacts kept the surface hot and molten. It's hard to imagine a more hostile environment. Yet this inferno was actually laying the foundation for everything that would follow. The Hadean was Earth's basic structure formed, when its atmosphere began to develop and when the moon was born. During the Hadean period, Earth experienced global volcanism on a scale we can barely imagine today. Volcanism means volcanic activity, or eruptions of lava, ash, and gases from beneath the surface. But this wasn't just a few volcanoes here and there like we have today. This was planet-wide. Volcanoes were erupting everywhere, constantly, releasing vast amounts of gases and lava. These eruptions were crucial for forming Earth's early atmosphere. The gases released included water vapor, H2O, carbon dioxide, CO2, and nitrogen, N2, and other compounds. Without these volcanic gases, Earth would have had no atmosphere at all. The volcanic activity was so intense because Earth's mantle, the thick layer of hot rock between the core and the crust, was much hotter back then than it is today. This created unique types of lava flows called komatitic lavas. Komatites are ultra-high temperature lavas, around 1600 Celsius or 2900 Fahrenheit, that were so fluid they could flow incredibly fast, almost like water. We don't see komatitic eruptions today because Earth's interior has cooled down. These massive lava flows covered and recovered the surface repeatedly, slowly building up the beginnings of a solid crust. While volcanic activity was intense, an even more dramatic force was reshaping Earth: meteorite bombardment. The young solar system was a messy place, still filled with leftover debris from planet formation, asteroids, comets, and planetesimals that hadn't been swept up yet. Many of these objects crossed Earth's orbit and slammed into our planet. These impacts delivered immense amounts of energy. When something massive hits at tens of kilometers per second, the kinetic energy of motion converts instantly to heat. Large impacts would melt the surface over huge areas, creating new magma oceans. Really big impacts would fracture the crust, causing it to crack and break apart like an eggshell. The young Earth's landscape was in constant flux, constantly being reshaped by these cataclysmic events. A cataclysm means a violent upheaval or disaster. Craters would form only to be filled in by lava flows or obliterated by the next impact. Scientists think there may have been thousands or even millions of impacts during the Hadean, though the largest ones were relatively rare. This bombardment continued throughout the Hadean and into the next eon, gradually declining as the solar system cleaned itself up. Some of the most colossal impacts during the Hadean were so powerful that they could literally boil Earth's oceans. Now, during most of the early Hadean, there probably weren't stable liquid water oceans yet because the surface was too hot. But there may have been periods when the surface cooled enough for water vapor in the atmosphere to condense, turn from gas to liquid, and rain down, forming temporary oceans. When a truly gigantic asteroid or comet struck, the impact energy would be enough to vaporize these oceans, turning all the liquid water instantly back into steam. These ocean-boiling impacts would have completely reset surface conditions, creating what scientists call impact-induced steam atmospheres. The entire planet would be shrouded in hot water vapor for thousands of years until it cooled enough for the water to rain back down. If any primitive life had somehow started to form, which is unlikely but possible, these events would have challenged or even destroyed it. These catastrophic impacts were fortunately rare, maybe only happening a few times during the entire Hadean, but they show just how violent early Earth was. It's amazing that eventually, despite all this chaos, stable conditions emerged. While impacts were incredibly destructive, they also had a constructive side. They delivered essential materials to Earth. Many of the asteroids and comets that struck Earth weren't just bare rock. Comets in particular contained large amounts of water ice and organic compounds, carbon-based molecules. When these objects hit Earth and melted or vaporized, they added their material to our planet. Scientists think a significant portion, maybe even most of Earth's water came from these cometary and asteroid impacts. Without this delivery, Earth might have been too dry to support life. The impacts also brought organic compounds, which are molecules containing carbon that are important for life. These included things like amino acids, the building blocks of proteins, and other complex molecules. So while impacts were certainly destructive, they were also vital contributors to Earth's potential habitability, its ability to eventually support life. It's one of those amazing ironies of planetary science. The same process that was creating chaos was also delivering the ingredients for life. Without the bombardment, Earth might have remained a barren, dry rock forever. Now let's talk about one of the most important events in the Hadean, the formation of the moon. For a long time, scientists had different theories about where the moon came from. One idea was the accretion theory, that the moon formed alongside Earth from the same disk of material, kind of like a double planet system. Another was the fission theory, that early Earth was spinning so fast that a chunk broke off and became the moon. A third idea was the capture theory, that the moon formed somewhere else in the solar system and was later captured by Earth's gravity when it wandered too close. Each theory had some evidence for it, but also some serious problems. The accretion theory couldn't explain why the moon has so little iron compared to Earth. The fission theory required Earth to spin impossibly fast. And the capture theory couldn't explain how Earth's gravity could capture such a large object without either ejecting it or causing it to crash into Earth. Scientists needed a better explanation that could account for all the observed properties of the moon, especially some really important chemical evidence we'll talk about soon. The theory that eventually won out is called the giant impact hypothesis, and it's absolutely wild. This hypothesis, remember, a hypothesis is an educated scientific explanation, proposes that about 4.5 billion years ago, very early in the Hadean, probably only about 30 to 50 million years after Earth finished forming, a Mars-sized protoplanet, remember, a protoplanet is a large planetary embryo, crashed into Earth. Scientists have nicknamed this protoplanet Theia, after the Greek goddess who was the mother of the moon goddess Selene. Theia was huge, roughly the size of Mars, which means about half the diameter of Earth and about 10% of Earth's mass. This wasn't just an impact, this was the most catastrophic collision in Earth's history. The impact was so powerful it nearly destroyed both planets. It released more energy than anything else in Earth's history, equivalent to billions of nuclear bombs going off at once. This collision set the stage for the moon's formation and it had profound effects on Earth itself, possibly even contributing to Earth's tilt and the length of our day. So what exactly happened during this giant impact? Based on computer simulations, scientists think the collision was oblique, meaning Theia hit at an angle rather than straight on, probably at an angle of about 45 degrees. The impact was incredibly energetic. Both objects were traveling at several kilometers per second when they collided. When they hit, the energy was unimaginable. Significant portions of both Earth and Theia were instantly vaporized, turned directly from solid rock into hot gas and plasma. Other parts melted into molten rock. The impact ejected enormous amounts of material, rock vapor, molten droplets, and chunks of debris into space around Earth. Some of this material escaped Earth's gravity entirely and was lost to space, but most of it stayed in orbit, forming a huge cloud of debris circling our planet. Meanwhile, most of Theia's iron core, being very dense, probably sank through the Earth's mantle and merged with Earth's core. This means Theia's core is now deep inside Earth. The lighter rocky material from both bodies, the mantles, was what got ejected into orbit. Here's where it gets really fascinating. The ejected material didn't just float around in space forever. Gravity immediately went to work organizing it. The debris formed a disk around Earth, kind of like Saturn's rings, but much thicker, made of molten rock and rock vapor instead of ice. This disk is called a debris disk, or circumterrestrial disk. Circum means around and terrestrial means Earth, so it's an around Earth disk. The material in this disk started to coalesce. That means clump together surprisingly quickly. Computer simulations suggest the moon would have formed in as little as a few hours to a few months from the debris disk. That's incredibly fast. The process works similar to how planets form. Particles collided and stuck together through accretion, building larger and larger clumps. Eventually, one dominant clump formed that swept up most of the material in the disk. This became the moon. At first, the newborn moon was much closer to Earth than it is today, possibly only about 15,000 to 20,000 miles away compared to today's 240,000 miles. It was also extremely hot, probably entirely molten at first with its own magma ocean just like Earth had. So how do we know that the giant impact hypothesis is correct? The strongest evidence comes from chemistry. When the Apollo astronauts brought back moon rocks in the 60s and 70s, scientists were able to analyze them in detail. They discovered something remarkable. The oxygen isotopic ratios in moon rocks were virtually identical to Earth rocks. Isotopes are different versions of the same element. They have the same number of protons but different number of neutrons. Different regions of the solar system have slightly different ratios of oxygen isotopes because of how and where materials form. Mars has different oxygen isotopes than Earth. Venus has different ones, and so do asteroids from different regions. But the moon's oxygen isotopes match Earth's almost perfectly. This is really hard to explain unless the moon formed from Earth's material. If the moon had formed independently somewhere else, capture theory, or even alongside Earth but separately, accretion theory, it should have different isotopes. The identical isotopes strongly support the idea that the moon formed from material blasted off of Earth and Theia, which had probably equilibrated with Earth-like material. Additionally, scientists think Theia's remnants, whatever didn't end up in the moon, might still be inside Earth today, possibly as large globs deep within Earth's mantle. What an incredible journey through early Earth we've had today. We've seen how the Hadean period from 4.54 to 4 billion years ago was a time of unimaginable violence and chaos. Earth was a molten ball constantly reshaped by global volcanic eruptions and devastating meteorite impacts. Some impacts were so powerful that they could boil away oceans. Yet through all this destruction, something constructive was happening too. Impacts were delivering water and organic compounds that would later be essential for life. And then there was the ultimate cataclysm, the giant impact with Theia that nearly destroyed Earth but instead gave birth to the moon in a matter of hours or months. The identical oxygen isotopes in Earth and moon rocks prove that they share a common origin. What's amazing is that this period of chaos wasn't just random destruction. It was actually creative, sculpting our planet, seeding it with essential ingredients, and giving us the moon that stabilizes Earth's tilt and creates our tides. The early Earth story shows us how dynamic and interconnected planetary formation really is. Out of violence and chaos came the foundation for everything that followed: continents, oceans, atmosphere, and eventually life itself. Thanks so much for hanging out with me at Nog's house today. Next time we're going to talk about what happened once Earth cooled down enough for liquid water to exist. We're going to explore the primordial soup and how the first life might have formed in Earth's early oceans. That's going to be really exciting. I hope you'll join me for it. See you next time.